Well, here's our building, and it's on fire. And maybe there's a guy hanging out the window screaming. But never fear, the fire truck is here, and here's its ladder leaning against the building. And we told you that this height here is 6. And then we can label this right triangle with X, Y here, and then Z for the length of the ladder. And we're given that this ladder is increasing in length. So that's dz dt, and that's 0.2 feet per second. And we're also told that the fire truck is backing up. So that's telling us about dx dt. But if the truck is backing up, then dx dt is negative. This distance is shrinking. So dx dt is minus 0.5 feet per second. And we want to know how fast the top of the ladder is moving up the building. So what we want is dy dt. And we want it when the ladder hits the gargoyle. And we said that the gargoyle was 30 feet above the ground, so that means y is 24 because we've got this 6 that we have to subtract. And we also want it when x is equal to 7. Okay, now there's a lot of moving parts here. Both x and z are changing, and y is dependent on both of them. Thankfully, the equation that links the 3 variables is not so bad. We have a right triangle, so y squared plus x squared equals z squared, just by the Pythagorean theorem. And that's an equation that holds for all times, so we can differentiate implicitly. We can take d by dt on both sides. On the left, the derivative of y squared is 2y, but since it's with respect to t, we need this factor of dy dt. Similarly, differentiating x squared gives 2x dx dt. And then on the right, same thing. We'll have 2z dz dt. And we can cancel all of these 2's by dividing, and then keeping the y's on the left, we get y dy dt equals z dz dt minus x dx dt. Now, here I want to take a moment to point out something about the signs on the right. We have 2 terms, one involving z, one involving x. They both contribute to dy dt. The dz dt term has a plus sign, and dz dt itself is positive. It's positive 0.2 feet per second. So together, that's making a positive contribution towards dy dt, towards the ladder moving up the building. And that makes perfect sense, because dz dt is referring to the lengthening of the ladder. The x dx dt term, that has a minus sign. But dx dt is negative 0.5 feet per second. So the combination of those 2 facts tells us that this term is also going to contribute positively to the ladder moving up the building. And that also makes intuitive sense, because the change in x, that's the truck backing up towards the building. And of course, that would push the top of the ladder up. My point here is that if you understand what's going on in your scenario, you can really see that in all of the terms that you're going to get from your calculus. So making sure that they all contribute in the proper way is something that you can use to check yourself. So for instance, if we had forgotten that dx dt is supposed to be negative, this would be a place that we could have realized our error. All right, now all that's left to do is to plug in and solve. We want dy dt, so I need to divide. I'm going to put 1 over y on the right, but y we're saying is 24, so we've got 1 over 24. and then we're multiplying by what's remaining on the right. So z, well, we don't have z written down yet, but we do know that at this moment that we care about, y is 24 and x is 7, so we can just use the Pythagorean theorem. And if you do that, you'll get that z equals 25. So I'll put that down here, and then dz dt we know is 0.2. And then we're subtracting x, which is 7, and then dx dt is negative, so I'll put a plus here and then 0.5. And then if you do all the arithmetic, you'll just get 17/48. And this is all measured in feet per second. So that's our answer.